Question 5. So it says, given that y equals 3 sine theta over 2 sine theta plus 2 cos theta for that domain, show that dy by d theta equals that. So for this one, notice that it's a fraction, a quotient, so we're going to use the quotient rule to differentiate it. Now don't worry if you can't remember the quotient rule, because the quotient rule is in the formula booklet here. So if we scroll down, we can see here, there it is right at the bottom, zoom into that. So I take that, copy it out, as you should do in your exam. Copy your formula out from the formula booklet, write it on your page, so that you don't have to keep flicking back and forth. So I've put it there. There it is there. Make that a bit smaller. So I'm just going to pop that there. Right, so f of x over g of x equals that. Right, so our f of x is what's on top. So f of x, or in this case we're dealing with f of theta, equals 3 sine theta, which means that f dash theta equals 3 cos theta. Differential of sine is cos. Then we've got g of x on the bottom, or g of theta, equals 2 sine theta plus 2 cos theta. And that means that g dash theta, we'll differentiate sine, we get cos. So 2 cos theta. Then differentiate cos theta, we get minus sine theta. So minus 2 sine theta. Right, so now subbing in at the formula, which implies dy by d theta. And just a point here to make, if you haven't got a formula book while you're trying to do these particular exam questions, then putting it quite frankly, you're being daft. What you really need is a formula book to hand, because there's so much in there that can help you. So there's no need to remember the quotient rule, there's no need to remember the compound angle formulae when it comes to them. You really must, when attempting exam papers, have that formula booklet to hand. So if you haven't got one, print one out. If you can't print one out, bug your teacher until they do. It's a must when you're revising. So dy by d theta equals, so we've got f dash theta on the top. So f dash theta, which is 3 cos theta, times g of theta. So times 2 sine theta plus 2 cos theta. Okay, then there's take f of theta, so 3 sine theta, g dash theta, which is 2 cos theta, take 2 sine theta, all over, nice bit of colour contrast there, all over g of x squared. So g of x squared, g of theta squared, in this case, 2 sine theta plus 2 cos theta, all squared. Right, so let's simplify that now. So the top equals, so let's multiply out the bracket. We get 6 cos theta sine theta plus 6 cos squared theta, take, so minus 3 sine theta times 2 cos theta, so take 6 sine theta cos theta, then 2 minuses make a plus, plus 6 sine squared theta, all over and we'll hold off multiplying out the bracket for now. There might be some nice simplification that happens. So 2 sine theta plus 2 cos theta squared. So simplifying the top, notice that the 6 cos theta sine theta cancels with the 6 sine theta cos theta. So that means on the numerator we get 6 lots of sine squared theta plus cos squared theta. An exam technique, and a show that question, which is what it said there, what we need to do really is show every step. So we could have written, we can deduce that 6 cos squared theta plus 6 sine squared theta is just 6 lots of 1. However, it's better to show it like this. in a show that question. Leave no marks to chance. Spell out everything, even what you think's blindingly obvious. And I think we're going to have to multiply out this bottom bracket now. So let's do it at the side here. So we've got 2 sine theta plus 2 cos theta. 2 sine theta plus 2 cos theta. So that's equal to 4 sine squared theta, that's that one, plus, well, we're going to get 2 sine theta cos theta times 2 sine theta cos theta twice, so that makes 8 sine theta cos theta plus 4 cos squared theta. So on the bottom, we've got 8 sine theta cos theta plus 4 sine squared theta plus 4 cos squared theta. And this here, it's fine to cross that out because that's equal to 1. So equals 6 all over, and really spell out what that equals. Notice that this is the compound angle formulae, in fact the double angle formulae. So we've got 4 lots of 2 sine theta cos theta plus 4 lots of sine squared theta plus cos squared theta. Let's just make that fraction line longer. So again, this here we've spelled out that that's 1 now. And here we've made this blindingly obvious, hopefully, that this is sine 2 theta. If you didn't know that this was sine 2 theta, go to my trig ratios and compound angle formulae and double angle formulae videos. Get it learned, you need to know that for the exam. So equals 6 over 4 sine 2 theta plus 4. Let's see how that compares to the answer. So see that it wants it in the form with just a constant on the top of a 1 plus sine 2 theta on the bottom. Okay. So that's equal to 6 over 4 at the front. So take out a factor of 6 over 4. So the top becomes 1. 6 times 1 is the 6 that we need on top. And the bottom, 1 plus sine 2 theta. So what I've done here, I've taken out a factor of 4 from the bottom. So I get 4 times 1, which is 4. And I get 4 times sine 2 theta, which is 4 sine 2 theta. But notice the constant needs to be on the top. Well, 6 over 4 simplifies to 3 over 2 over 1 plus sine 2 theta. And that's the format that it wanted it in. For more videos like this, subscribe to our YouTube channel. And to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.